All right, so this is question 8, and this is a question that was done very, very badly, and I think a lot of you were scared because of the negative marking, and it is one of the difficult questions in this paper. This is not supposed to be the question that everyone gets right, but you should be able to pick up some marks. You just do need to know your work, and you've got to know your theory in order to answer these sorts of questions. So the way the negative marking was applied is within each question. If you got something correct, you got half a mark. If you got something incorrect, you got minus half a mark. If it was left blank, then it didn't affect you at all. All right, so let's just consider these questions. I'll just go through them with you, and then you can just see how it should be. It's theory that you should know. It's not like there's a lot of weird stuff going on with this question. All right, so an SN2 reaction occurs in one step. Yes, SN2 occurs in one step. That is true. SN2 reactions involve carbocation intermediates. Well, no. If they occur in one step, then there is no carbocation. So that had to be false. Occur well with primary and not tertiary alkyl halides. This would have been more of a trickier question. This is one that I would have expected most of you to have left alone. But because SN2 reactions occur in one step, they need to be sterically unhindered. So something like that reacts actually a whole lot better than something like that. These don't undergo SN2 reactions. So this statement is true. Again, I would have expected only a few of you in the class to have kind of picked up on that statement somewhere in your textbook and really picked up on it. And this was a hard question. I would have expected most of you to have left this one empty. They result in the formation of alkenes. No, that's an elimination reaction. How can a substitution reaction give you an alkene? So that must be false. Never have a hydroxyl as a leaving group. Well, that's true. An OH is not a leaving group. It has to change. So an SN2 reaction cannot involve hydroxyl as a leaving group. This statement is true. Occur at an aromatic halide. No, no, no. This cannot happen. SN2 reactions do not happen. All right, we've taught you that this is not a leaving group. You should have got that. That's an easy one. Do not occur. It is false. All right. Okay, this question, I had some arguments with our lecturers or debates on one of the answers. Let's get to it. So, providing that beta hydrogen atoms may be present, so, all right, potassium hydroxide can. So, we're looking at something, beta hydrogen is these sorts of things with a leaving group here. That's one sort of thing. But you're going to see now with this question that there's one that doesn't need this. Mainly cause alkyl halide to eliminate. Yes, potassium hydroxide and ethanol causes eliminations. This is an alkyl halide. It's got beta hydrogens, so this is true. Mainly cause substitution in alkyl iodides. No, no, no. It's not substitution. We've taught you potassium hydroxide and ethanol is elimination, not substitution. Converts geminal dihalides to an alkyne. So, in other words, something that looks like that, geminal dihalide, goes to, say, the alkyne like that. Well, that we've told you, you have to use a very strong base, like sodium amide or potassium tertiary butoxide. This is not strong enough. It can't do it. A bit more of a difficult question, but if you knew your work, you would have got that correct. Maybe it would have been better just to leave it if you weren't sure. Convert a primary alcohol to an alkene. No, 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 no. You cannot take a primary alcohol and eliminate an alkene with potassium hydroxide. To do that, you've got to use concentrated sulfuric acid. This is false. Substitute aromatic bromides. Once again, no, no, no. These are not being substituted. We don't do any reactions on the aromatic halides, and so that question over there must have been false. And then the last one, hydrolyze an ester to a carboxylate. This is true. If you take an ester, O something, so R, and you reacted it with potassium hydroxide, and if it was in ethanol, it wouldn't matter. You can do it in ethanol, in fact, probably would, then our product would be the carboxylate. And by now you would know this from the reaction that you have done in practical 5. And if you'd studied, you would have known that this one. Anyway, there was a bit of debate over this because some of the lecturers felt I was being unfair with this, and they felt that that you would expect that there should be water present, and actually you don't need water present, so it is true. So what we did with this one is that if you answered false, we didn't take off a minus mark for this one. All right, so this one, if you answered false, we didn't apply negative marking just because some of the lecturers felt that I was being a bit unfair. Maybe I was. It was only half a mark. I'm not too stressed about that. Anyway, so that's how we should answer this sort of question. As I said to you, this is a difficult one. The negative marking, I have to have negative marking, otherwise you're guessing, and that's just not a fair way of making sure that you know an answer to this. Your best thing is be sure of what you say to get this, and if you're unsure of something, just leave it out. Leave a question like this to last when you've got some time to really digest this and think about something along these lines. All right, so that's the end of question 8.